We have already broached the subject of our keynote address tonight, but it is certainly one that has driven imagination. And if you have driven from Los Angeles to San Francisco or vice versa in the past 10 or 15 years, you probably noticed some changes along the way, and yet it always seems to be the same kind of drive. The notion of being able to travel between those two great cities, and not just San Francisco, but San Jose as well, since we're now larger than San Francisco, and being able to do that within a half a day is a phenomenal idea, and it is an idea that's well on its way to becoming reality. That does not mean there are some hurdles to overcome, be it the size of the bridge in San Jose, or if there will be a bridge in San Jose. But those are things that I'm not going to ponder, because our guest speakers tonight, our keynote speakers tonight, are gentlemen that have been working on this and will continue to work on this. It is a tag team, not in quite a wrestling sense, but our two gentlemen are Mr. Robert Doty, and he is the director of the Peninsula Rail Program, which right now entails the Caltrain corridor and the high-speed rail project. He is teamed up this evening with a gentleman who has, well, approaching 3 decades of experience in designing railways and constructing them. He is currently the project manager again for the California high-speed rail Caltrain corridor, and his name is Mr. Tim Cobb. And without further ado, if I can introduce again both Robert Doty and Timothy Cobb.
Well, thank you all. We always enjoy the opportunity to get out and talk about this exciting and important project, California High-Speed Rail. Really want to start off with the end in mind, and we got a short video about high-speed rail around the world, so we can all get in the mood here to envision what in just a few short years we're going to have here in California.
Monday morning in Tokyo. It is 8 a.m. and the Shinkansen Super Express is leaving for Osaka, whisking passengers out into the countryside and making the 350-mile journey in just 2.5 hours. Every day, the scene is repeated for still more passengers across the globe. In France, from Paris to Bordeaux. In Spain, from Madrid to Barcelona. In Taiwan, from Taipei to Kaohsiung. Today, throughout the developed world, high-speed trains are a fact of everyday life for millions of people, and soon will be for millions more. Increasingly, countries are turning to high-speed trains to meet the growing transportation needs of the 21st century.
These other countries have looked at their futures and said, modern high-speed rail's got to be a part of it, and an essential part. Without it, we can't grow, we can't prosper, we can't build the kind of society, the kind of economy that we want.
Is it reliable? Is it high-tech? Yes. Are the beautiful trains to travel on? Absolutely.
Sleek, modern, and employing the latest state-of-the-art technology, the story of high-speed trains begins nonetheless more than 50 years ago. In 1964, the first Tokaido Shinkansen left Tokyo, moving at speeds of 130 miles per hour and shuttling 100 million passengers in its first 3 years in service. It was an unparalleled success and set off a transportation revolution worldwide. In 1981, the TGV began operations in France, drawing 1 billion passengers in 20 years and revolutionizing the way Europeans traveled. Today, 12 countries throughout the world have high-speed rail systems in place, with the reach of new high-speed lines ever expanding. 8 more countries, including Mexico, Russia, and Argentina, are currently building or planning their own high-speed systems, and will soon have them up and running.
No European country, certainly not Japan or many countries in Asia these days, would think of moving into the future without high-speed rail. I mean, they're all investing in it. Every European country, every part of the European community is investing heavily in what will be a first-class high-speed rail system that will connect the entire European community.
Today's high-speed trains are faster, quieter, and more energy efficient than ever. Today's 8th generation Shinkansen trains routinely operate at 185 miles per hour. The French TGV now operates at 200 miles per hour in regular revenue service. China has recently opened a new train line designed for speeds of up to 217 miles per hour. And high-speed train technology has not yet reached its limits. An operational German ICE train has reached 252 miles per hour. Test runs on Japan's Shinkansen have reached 277 miles per hour. And in 2007, an experimental French TGV train reached a world record rail speed of 357 miles per hour.
Thanks to the latest improvements, it's now possible to go from downtown London to downtown Paris in 2 hours and 15 minutes. And of course, it's getting enormous traction.
For passengers, travel on high-speed trains offers unparalleled reliability, safety, and accessibility, rivaling point-to-point travel times for air travel on trips up to 500 miles, and easily outstripping travel times by automobile and conventional rail service. In the densest urban centers in the world, high-speed trains provide a complementary transportation technology that eases congestion on highways and frees capacity at increasingly crowded airports. By seamlessly integrating high-speed trains with airports and other modes of transit, such as subways, light rail, buses, and commuter rail, high-speed trains offer passengers a functional transportation alternative, while at the same time promoting sustainable development patterns within existing urban cores. Clean electrically powered high-speed train technology also pays critical environmental dividends. One traveler's trip on a French TGV high-speed train produces 4 to 5 times less carbon emissions than travel over the same distance by air.
Money spent today is going to go a long way in the future, and it's evidenced by the other countries that have high-speed rail. People are happier that they're getting to work on time, they're paying less for transportation costs, and they're helping the environment. California, I believe, has to look to high-speed rail as the #1 priority.
If you look at the other countries of the world that have high-speed rail systems, Japan, France, Germany, California is about the same scale, and we're approaching the same density of people. You know, France has 55, 60 million people. We're going to reach 50 million people by 2030, it's estimated.
California is perfectly fitted and set up in where the major centers of population are, where the distances are, where the people need to move.
San Francisco to Los Angeles, that's about 400 miles, 420 miles. Those are systems that lend themselves to high-speed rail.
Around the world, high-speed trains are a proven, safe, and environmentally sustainable technology for meeting the transportation needs of the 21st century. By offering a fast, frequent, and enjoyable travel alternative, high-speed trains fit in perfectly with a regional intercity transportation matrix that works. It can work in California, too.
All right, so show of hands, show of hands, who's had the opportunity to ride a high-speed train somewhere around the world? All right, great, good cross-section the crowd has. I think all of you that have will certainly agree that it's just a wonderful way to travel. You can show up at the station 5 minutes before the train's going to leave. It's always going to be on time, and during the trip you're not strapped in. You're able to in comfort do work or go to the bar car and have a refreshment if you want. So let's talk a bit about the California high-speed rail system. What is it? The overall system is about 800 miles connecting Northern California to Southern California. It's broken into a number of different sections. It'll be serving LA, Orange County, the Inland Empire, all the way down to San Diego, down through the Central Valley, and of course the San Francisco Bay Area and on up to Sacramento. We're looking at having travel times between San Francisco and LA in about 2 hours and 40 minutes, travel times between San Francisco and San Jose in about 30 minutes, Once we get down in the Central Valley, we'll be looking at top speeds of about 220 miles per hour. And up here on our corridor, the Caltrain corridor, we're looking at top speeds of about 125 miles an hour. On the Caltrain corridor, we get a station up in downtown San Francisco. There'll be a station at Millbrae for the airport connection there, and a station down in San Jose at the Diridon station. Beyond that, we're also looking at the potential sites of an additional midline station at Palo Alto, Redwood City, or Mountain View. It would be at only one or none of those. We're just starting on the study and analysis of those right now. So an important thing happened back in November 2008. The voters of California approved $9.95 billion in rail bonds, and that really kick-started the program here. On top of that, just recently, many of you may have heard, the state of California high-speed rail program received $2.25 billion in stimulus funding, and that will be split up somehow between 3 different corridors. The Caltrain corridor is one of the eligible ones, LA Anaheim, as well as the Central Valley. So as I said here, the San Jose to San Francisco section is one of the phase 1 corridors. So how did we get here? The project really started back in 2003 when the statewide programmatic environmental document was started, and that document was finalized in 2008. At that time, there was another study that was undertaken for up in the Bay Area to look at how the high-speed rail system came into the Bay Area. That study started in 2008, and actually I think it started in about 2006 and completed in 2008. Where we are now, on the project specific, we're working on developing the project-specific engineering and environmental document, and we're in that second box there called alternatives analysis. We've gone through the earlier scoping phase where we've gone out, had public meetings, collecting ideas from everyone on what the different options that folks thought we should look at. As part of the programmatic agreement document, what was determined was the Caltrain corridor would be the corridor that we would follow, but what hadn't been determined is what design options or vertical design options really would we end up at. So we're looking at a number of aerial, at grade, and below grade solutions throughout the entire corridor, and at the end I'll talk a bit more in specific about that. So as I said, we're in the alternatives analysis now of just looking at all those various design alternatives. We're looking to have a draft document completed shortly. The next major milestone that we're looking at is having a draft environmental document out in December of this year, and then having a final record of decision by September of 2011. And with that, I want to hand it over to Bob, who's really going to talk about how do we integrate this California high-speed rail project into Caltrain and all the work that Caltrain has planned.
You might notice, oh, he'll be back. You might notice there's some cards on your table to write questions down for Tim. I already have mine filled out and handed in, as a matter of fact. I've had the fortunate opportunity to work high-speed rail. I'm one of the very few Americans that has, and that's sad. I worked in Asia for 5 years and went on to Korean high-speed rail. Worked on Channel Tunnel Rail Link for about 3 years. Matter of fact, I mentioned to Tim, I actually went to an engineering awards dinner in the UK where they acknowledged the Engineer of the Year. And they went through and finally gave a gentleman the top award. And his top award was a round-trip ticket to the Bay Area. I went home and told my wife it's time to go home because we'd been gone too long. And I'll tell you, it was. I did something crazy. I actually had to, only way I could get home because they were making so much money off of me over there is to actually retire It's really complicated in Europe because in Europe I'm only 16 Celsius. It lasted about a year, and I woke up one morning and there were want ads on my chest, and my wife says, "This isn't good for you." And I went to Caltrain, and we did something very interesting at Caltrain. It's a very traditional railroad with very traditional technology. I like to say in the United States we're unencumbered by technology. It's absolutely true. What we actually did is we looked at this service, and without adding equipment or adding employees, we created a new service model. And the essence of it was runtime. Reliability, safety, security, but reduced runtime. And I'm sure many of you know what's happened over the last 5-6 years. We went through 5 fare increases without any elasticity of demand recognized at all, which meant that we actually created demand. And that's very important when we're going to talk about high-speed rail, because in the United States, people like the concept, but they don't know the product. And that's very big because, for example, BART, you say, well, we're going to extend BART. Everybody knows what that looks like. Most people that we're dealing with don't know what high-speed rail really looks like. So we have a big job ahead of us. Now, 3 years ago, as it turned out, because I tend to be a bit restless, I decided to go talk to the FRA about bringing in European-style equipment into the United States for the very first time. High performance, lightweight, very good acceleration, deceleration, high reliability, modular components, so you don't lose a train, you lose a component. And I sat down with the FRA, and basically the first thing the guy said to me was, "You can't submit a waiver we can't take apart." And I said, well, that's great, because I don't even know how to submit a waiver. I've never worked heavy rail in the United States. I worked stuff all over the world. And we actually made a deal. And that deal was we were going to work together with the FRA using an entirely new process, which is now becoming standard. Actually, we're the poster boy for this approach, on the hazard assessment analysis, which many of you use in your everyday life, but it's never been used in the rail industry. The code of practice in the Federal Railroad Administration is based on the last accident, which is always a good strategy. Always correct what's already happened and don't worry about what's going to happen. So you have a body of regulations, some of them dating from the 1930s, that just really aren't relevant. Now, we didn't know what was going to happen, and as fortune would have it, we actually teamed up with many European manufacturers for UIC, European Standard Equipment, which is what most of the high-speed rail is. I don't know if any of you know about the practicum that happened over the last week with UIC all over the United States. I was fortunate enough to be one of the presenters, and it was absolutely fantastic to talk to peers from all over the world. There's a lot of good understanding out there. But we decided we would run standard tests with the UIC equipment that the FRA requires American equipment to pass. One of those tests was hitting a truck at speed. And the U.S. standard is hitting that truck at 30 miles an hour and that there's no intrusion into the occupied space. That's considered a successful test. So using the simulation model in the Volpe Center, and we use standard approaches, we tested it, and UIC passed. And we said, wow, that's pretty good. But we got a little curious because now that we've hit that standard, we said, well, you know, here we go. Let's up the speed to 50 miles an hour and see what happens. You can't stop us, you know, we just got to know what the next question is. And the American equipment failed, of course, but the UIC equipment didn't fail. So we said, well, let's up the speed to 70 miles an hour. The UIC equipment did not fail. The crash energy management that's built into that equipment is so advanced over anything we do in the United States, it is safer. We now have a waiver request into the FRA to be the first operator in the United States to run UIC equipment in mixed traffic on our railroad. And they put conditions upon us to do that, and you'll see them on this slide. The first thing they said is, obviously, the equipment has to survive the crash energy management, and we have proven that. The second thing we have to do is put in, at that time, a control system to add safety, which is overspeed, roadway worker protection, and train-to-train protection. We started on this quite a while ago to create an overlay on top of what Caltrain's current signal system is. And now it's a mandated program, happened afterwards because of some unfortunate incidences. We call PTC, Positive Train Control. We've actually been in front of the curve on this. So we're ready to go to bid with that. The other thing they told us to do is a grade crossing improvement program. And the program we proposed to them, that's part of our waiver, improves every single grade crossing by a factor of at least 3, and in some cases up to 12. So that's where we were. But then I got a little bit of a problem. I didn't have any money. There we go again. You have to understand that Caltrain, the JPB, is owned by 3 different counties, and different agencies have their own transit systems, so we get what's left over. We do not have a permanent funding source, so we're always asking for the dollar they don't need. And I think we've done pretty well, but it's a tough, tough thing. So we didn't have any money, and actually, to be honest with you, we were on the verge of success, and then the big dollar sign showed up. So what we went out for to Match.com, and we said, we need a partner. And lo and behold, we found a partner. We need an electrified system. They need an electrified system. The design we've been building for Caltrain is exactly the same design that is needed for high-speed rail. Not coincidentally. I mean, really, not coincidentally. Come on. There we go. They need high-performance vehicles of UIC. That's what we're already in the market for, UIC equipment to run in mixed traffic. So our approval process for UIC is exactly the same approval process that high-speed rail is going to need. They need a control system. We need a control system. Starting to sound like a pretty good match so far. We need grade crossing improvements, but lo and behold, they need grade separation. Well, that's the ultimate grade crossing improvement, isn't it? Now, people say, well, yeah, it's going to be safe. We actually at Caltrain, I mentioned it to Tim today, we have a place that's on a berm that's about 20 feet high. We actually had a car land on top of that one day. The guy hit the bottom of it at 65 miles an hour and landed on top of the track, and we hit it. So if people say, oh, if you stick it up in the air, you can't hit anybody, sometimes they come to you. He won the Darwin Award, by the way. What we decided to do is create an MOU between the 2 agencies because it's awfully, awfully close. And we've done a lot of work within the JPB that Caltrain, that high-speed rail can build off of. We've done a lot of the footwork. We have environmental clearance for an electrification program. We're already writing the standards for the state for electrification. All of that's transferable as part of the high-speed rail project. So this is starting to knit here pretty well. So what we did is we actually created a couple of MOUs to create a consolidated organization. And that organization we now call the Peninsula Rail Program. And in effect, the responsibility goes all the way to Gilroy. So what we're doing is combining what's already been done and the best efforts and the skill sets. You know, one of the things that really bothered me when I went to the UK, they said, you know, we brought you here for your management. Because from a technical perspective, the U.S. is a developing country. They're right. And you know, it inspired me. Because, well, I'll give you an example. I went through Spain with the Korean delegation, I think it was in 1994. And Spain was much where we are today. Struggling, trying to define an industry, trying to bring talent in, borrowing from everywhere. I went back a year ago, and you have an industry in Spain. And what's most exciting, because I heard it earlier, the engineers are young because it's not building a railroad, it's building a system. And that inspires, and that gets people excited because it stimulates. It's not your grandfather's railroad. It's not a fast train. It's a system, and that inspires ingenuity. I think we can do a pretty good job with it ourselves. So the vision, you've seen the pictures, and they're all wonderful. But the thing we lose sight of is the alternative, and we should not lose sight of it. I saw a Discovery Channel program, I think about 3 months ago. By the way, that's the discussion we have is whether that's an ostrich or an emu, because that's EMU, and for those of you who know what that means, that's an inside train joke. Nobody else gets it. I saw a Discovery Channel program on one of the places I live, China. And the question was, how long will it be till there are as many automobiles running in China as there are in the United States? Now, I don't know the whether it's factual or not, but it was shocking. And I'm thinking numbers, and they go, 4 years. If you think we're going to have enough gasoline to go around, you're missing the point. We're not. We must develop other means of transportation. I lived in London. One of my contractors was in Paris. A tough job, huh? I had to go to Paris every 2 years. I just love saying that, you know. It's like, go to Paris. Oh, you know. I didn't fly one time because I couldn't afford the time. Instead, I went down, I got on a train, I had a nice meal, I talked to my compatriots, I made telephone calls, I got off in downtown Paris, and I went to work. And when it's time to come home, end of the day, I'm tired, I wasn't worried about a road or anything else. You know, there's something intrinsically wrong, especially like when you go to an airport, and all of you, I'm sure, fly various places, there's just something irritating about having to take your clothes off to get on an airplane. You know, we know why we're doing it, but it doesn't sort of bug you? And you're sitting there going, gee, there's got to be a better way of doing this. You know, my philosophy is, if you take off your clothes getting on a high-speed rail train, it's because you wanted to. Yeah, there you go. You've seen me before. Well, that's a nice slide. There we go. Now, we're in the outreach program, and let me tell you, the first part is what's desired. And I use this analogy. I said it's like asking your child what you want for Christmas, and they say a pony. And you say, but we live in an apartment. If you ask an open question, you're going to get an open answer. That's rational, and that's sort of where we started out. But the other part of that is you have to put it through a filter called feasibility. And feasibility is as much engineering as it is anything else. What can you actually do with what you want? And what that does is it starts modifying the equation. But there's a third part of that. Whoops, I'm going to back up there because I skipped through it. There's a third part of it, which is what can you actually fund? So you have desirability, achievability, and feasibility. And what you end up with when you're done with all of that is where you end up with a solution. It is always a compromise. It is always a compromise. So we put a process together that's never been used for a project this big before. And it's context-sensitive solution, and many of you probably used it. And it's used a lot on relatively small projects. We're going to roll it out for the entire peninsula. The concept is basically to incorporate the community into the process, to get feedback, but just importantly is to get the community to understand the decision-making process. When I've worked overseas, I've always talked about the cultural aspects of the product we're delivering. When you go to someone else's house, you want to know what it is they expect. Well, believe it or not, we have cultural aspects in the United States. And one of ours, which is also good and bad at the same time, we are known in the world for our ability to compromise. We are at our best when we work together and find the solution. And that's actually why they asked us to go to the UK. Half of my staff was French, half of my staff was British. They couldn't talk to each other. They put American in the middle. They did agree on one thing, they hated me. But you know what? We were on time and we were under budget, because what we do as Americans is we find the solution, and we understand it's not the perfect thing we all dream of. That is our strength, and that's what this process is all about, incorporating people into the decision-making process so they understand why you are where you are. That's ownership, too, by the way. We have a lot of partners. A lot of partners. Our email list right now is over 18,000 people just for the peninsula. We have talked to hundreds and thousands of people. We've had 400 and 500 people show up for one evening. Actually, one evening and part of a morning. So that's what we're going to do. It's never been done, but what the heck, that's the fun part of it. It's incorporative. It's really trying to spread the information necessary to build a decent system, because the one thing we hear over and over again is do it right. And I will tell you, for the rail industry in the United States, that is something they don't understand, because they're not going to do it right. They're going to do it like they always have. And that's why we have to do something totally different. So I'll let Tim finish this off.
All right, so you heard Bob talk about the optimal solution. So here we have 48 miles, 17 cities, 46 existing grade crossings. You know, how do we get there? It's not easy, but it's a lot of fun. So what we did here, you can see on this map, and many of you hopefully have been out in some of the public meetings we've had, is we broke the corridor into 10 different subsections to really start breaking it down, and that's helped us in some of these community meetings and community workshops to really focus people on areas. You can't get too small because we are, end of the day here, we're building a high-speed train system, so we can't be constantly changing from above grade to below grade to back at grade and having that porpoising effect. You know, we could have another Great America ride. We don't need that. We have one down here we can all go to. So there's kind of that balance between looking at pieces big enough but then not too big so you can really get your arms around it. And it is, as Bob said, the CSS process is a very exciting process. As engineers, we're getting some really great feedback, getting it up in and getting it in early, so we haven't designed something and then we get down the road 6 months from now and someone else that lives in a community brings up a really good idea. It's a lot better for us to get that now to keep this project on pace. So a few of the important dates. We talked about the alternatives analysis report that we're working on now, and that's the draft is actually under review by some of the federal agencies. We intend to be having some countywide workshops. The dates of those in Santa Clara on March 24th, San Mateo on the 25th, and up in San Francisco on April 6th. These will be workshops. We'll have lots of tools as part of the CSS process. There's this toolbox that really is going to help people understand what are the implications of the different scenarios, different design options of above grade, below grade, and at grade. Our goal here is to really look at all of those solutions, work with the communities, with the cities, and come up with the best design for each of those. So then we can really make an intelligent, rational decision on what is the best option. Here's just some contact information. The PRP has set up a website. There's a lot of great information that you can get on there. Also, the California High-Speed Rail website has an immense amount of good information. If you do want to get added to the email list, the best way to do that is to email the PRP website. We've got I don't know how many hundreds of thousands of people now on there. We give occasional updates whenever anything new is coming out. Give those updates to people so they know to go to the website and get that information. And with that, we're going to go to some questions, and Bob, I'm sure, is anxious to come back up here and help me out here.
And if anybody has questions at your table, if you would like to raise your hand and wave your card, and I'd be happy to, actually, Steve, why don't you take that half of the room and I'll take this half if you have a card.
The students are helping us as well.
Okay. And you have a question. If you'd like to jump in and begin. Question?
This, of course, has a high degree of sensitivity. It says, how will you base suicides basically on the railroad? If not addressed, we'll put the system at standstill, and that's absolutely correct. Now, the one thing that happens with high-speed rails is a fully enclosed environment, very similar to what BART is with fencing and protection and things like that. That makes it far more difficult to do that. But the reality is, it can happen. It can happen because people figure out a way to get around the system. We have had it actually happen at a station platform and at a very low speed. So it would certainly make it more difficult to occur, but as we found out from our European counterparts, because I actually talked to them about this, I said, what do you do? And the problem is they have the same problem we do. So there will be more constraints and more restrictions because of the fencing and the way it's built, and if it's aerial, obviously it's much harder to get to and things like that. But the reality is it can't be perfect.
I have a question for Bob, and that is, To what extent will the existing Caltrain system remain or expand when the high-speed system is born?
The intent is that with the signal system, which will allow the Caltrain corridor to run up to 12 trains an hour, as well as the high-speed rail system. That doesn't mean what you're going to run. I'm talking about the design requirement. And the fact that it's electrified and the fact that we have higher performance vehicle. We will still maintain our minimum trip time for some trains at 60 minutes, but the maximum trip time end to end will be only 70 minutes. And that means that we'll be able to virtually double the number of trains and considerably improve the capacity because the trains will also be longer. One of the advantages of EMUs is with the diesel haulage, if the train gets longer, the performance regresses because of acceleration, deceleration. With EMUs, electric multiple units, you don't have that effect. So you can have an 8-car train and get exactly the same effect you can with a small train. So it actually vastly improves the capacity.
Okay, another question for Bob while you're there. Why would security be so minimal? Airlines are just as high value as high-speed transit.
Good question, and there is a definite difference in how security is handled around the world for trains and for airplanes. Part of the reason is, you know, you can do a very small thing to bring an entire airplane down with everybody on board. You really can't do that equivalent small thing on a train. And this true security, boy, I always hate to say this because I know the answer, but I don't want to say it. The true security risk is not on board the train, and I'll just leave it at that.
There's the best two from the other side of the room.
Okay. I'll leave this as a toss-up question. Is there any chance of, I apologize, am I seeing UIC equipment being manufactured in California?
Well, glad you asked that question. I forgot to mention it. When I was a chief negotiator for the Korean high-speed rail project, one of the requirements for the successful bidder for the Korean high-speed rail project was to create a Korean rail car industry in Korea. That industry is now selling cars to Los Angeles. I believe that it must be embedded in our agreement, not for final assembly, but for the manufacture of these vehicles within the United States. I see absolutely no reason that can be part of the contract. And that's a lot of jobs.
We've got time for about 5 more minutes.
This, I believe, has been in the news recently. Which will be used to get to San Francisco or San Jose, Pacheco Pass or Altamont Pass?
Thanks. Who's this guy? As it stands right now, as you well know, the environmental document has been reordered. We have been instructed to continue with the alignment through the Pacheco Pass until we are told to do otherwise. So all I can tell you, the instruction we have received from council, and this is a legal issue and it's still open, so I have to be cautious here, is that we should continue the development along the peninsula from San Jose to San Francisco.
Okay. A uniquely San Jose, Santa Clara County question. We've been talking about light rail here for many, many, many years. How does this still fit into the picture, especially in light of the current decline in light rail usership, that is?
Okay. One of the elements of a successful high-speed rail system is that it goes where people are. It is our nature and it is our character that if we get in an automobile, we will probably stay in the automobile or we will go to the airport. The attraction of high-speed rail is to be where people are because it's so convenient, that's what you take. That includes not only the central business district, but it includes the essential feeder systems to make that happen. And it's not only light rail, it's also commuter rail and how we interconnect, because another one of our projects is what we call Super ACE, is to bring more people in from the East Bay through the Altamont corridor to actually feed the system. So there's a symbiotic relationship here.
I think just building on that, one of the greatest opportunities we have is down here in the South Bay at Dearborn Station, where you have the interconnectivity of the future BART. You got the Caltrain, the ACE, the Capital Corridor, Amtrak, the light rail. So just a tremendous opportunity there to build something very amazing.
Okay, we've got time, I think, for one or two more. This is a quick one, I presume. How much will San Francisco to Los Angeles cost?
The last business plan, which was far more realistic, shows the extracted fare to be 83% of the average airfare, which is closer to international standards. I would reference you, there's actually a website in Europe that on the website compares all European airfares to high-speed rail fares, and in every single case it costs less to take high-speed rail than it does to take an airplane. I would assume we'll follow the same mode, but right now it's approximately 83%. Now I know everybody says, well, if I buy 3 months ahead of time I can go for $10 and things like that. We're talking about normal, you can always find a deal. That's okay. We can't carry everybody.
Okay. And in the big picture, what is the proposed cost of the system? This particular questionnaire recalled a $900 billion from the ballot measure description.
900 billion?
Yeah, the current year of expenditure budget in the business plan, I think, is 42 billion?
Yes, just under 43.
Just under 43 billion, which is year of expenditure. By the way, that is the first time they've used, for some strange reason, you all do it in your normal business. They always did it in today's dollars, and why? It makes no sense. They're now extracted to a year of expenditure at 40, just under 43.
Okay. And I think in light of time, let me ask this one question, because I know it's, again, been something in the news. How do we prevent kids from jumping in front of trains?
I don't know.
It's a difficult one.
This is difficult because I've had to be out there. Okay, I've been out there with the crews, and I will tell you, as painful as you feel, I can't tell you how painful it is to the people who are operating those trains, because it's our job to be there. And believe me, if we knew what to do, we'd do it.
Just as information, the Mineta Institute is undertaking a study right now of that particular issue, looking at, it's a problem nationwide, and they've just started that study, and I think, Bob, was it in summertime? Yeah. They thought they might have some initial results out on that study in the summer.
Okay. Let me ask one more, perhaps lighter question, and that is, we travel often to San Luis Obispo from San Jose. How might high-speed rail help us there?
We'll wave to you.
Well done. Thank you, gentlemen. Robert Doty, Timothy Cobb.